channel. I am Ameya and we are discussing about effect of zeta on the system response in a control system. Okay, so we know that for a second order system there are two controlling factors, one is zeta and one is omega n. So depending upon the value of zeta you can easily classify system on the system response. Okay, so first type of system is under damped system. So this is the graph by which you can plot the response of a system. On x-axis you have time, on y-axis you have the output, and you have the final value. Okay, so my system starts with 0 and it tries to achieve the final value. It overshoots the final value and then settle down after some time. So this type of response is called the underdamped system response, where your value of zeta is less than 1. Okay, so value of zeta will be less than 1. So whenever zeta is less than 1, system will always overshoot the final value and then settle down after some time period. Okay, for critically damped system there will not be any overshoot. System will go about the final value and it will try to reach the final value. So this is a critically damped system where your value of zeta becomes 1. Okay, so this is a critically damped system where your value of zeta is equal to 1. And then there is a third type of system that is called overdamped system, which is having zeta greater than 1, and response of a system will be much more slower compared to critically damped system. So for overdamped system, zeta is going to be greater than 1. So for overdamped system, zeta is greater than 1. So you can easily understand the behavior or response of a system depending upon value of zeta. If it is less than 1, it is underdamped system and there will be definitely an overshoot. If it's a critically damped system, it is zeta equal to 1. If it is overdamped system, zeta is greater than 1. And if there is no zeta in your system, that is called no damping. Okay, so that is one more type of system which you have, and that will respond like a sine wave. Okay, no damping. Now how this value of zeta will help us: generally when we try to design a system, ideally it should be a critically damped system, there should not be any overshoot. But most of the systems which we observe are underdamped system, because underdamped systems are much more faster in responding. Okay, and also they get settled down fast. That's why we prefer underdamped system. Overdamped systems are very slow in response, in changing their response, and very slow in settling. So we avoid overdamped system. Critically damped are the ideal systems, and underdamped systems are high response, fast settling system. Okay, so and the value of zeta, how it will affect the, as I reduce the value of zeta, your system will overshoot more. Okay, so if my zeta is 1, it will be somewhere around critically damped system. So zeta is equal to 1. As I reduce the zeta, overshoot will increase. Okay, and as I decrease the zeta, increase the zeta more than 1, it will be over damped. So system is becoming more slow, and as I increase zeta, system is becoming more fast. Okay, so that is how you can easily predict how much overshoot you are getting from the system. If zeta is closer to 1, there will be less overshoot. If zeta is less, that is 0.2, 0.1, 0.05, then you will get highest overshoot in your system. So this is how the effect of zeta on your system response, and depending upon that you can classify those systems into underdamped, overdamped, critically damped, and no damping type of systems. Okay, this is what I want to discuss in this video. If you like the content, do share this content with your friends. Subscribe my channel for more videos. Thank you for joining.